Mike, over the course of your career, you've been exposed to pretty much the entire wave of telecom and the onslaught of the internet, and then obviously now the IoT really exploding. When you look at IoT, what excites you the most right now in the market?
I think it's a really exciting time in the market with IoT, specifically because just in the last few years there have been mega changes going on with both the technology and evolution of the market itself. We're seeing more and more intelligence getting pushed to the edge of networks out of necessity. When you're talking about trillions of devices, you can't backhaul all that data and handle it. So more and more you're seeing in more intelligent edges, a lot more consolidated functionality. The other big trend we're seeing is machine learning and AI being pushed closer to the edge. When you talk about things like prognostics and predicting failures, safety issues and so on, machine learning is a huge piece of that.
From your position, what do you think is going to be impacted the most with all of this intelligence on getting to the edge, or the AI/machine learning stuff getting to the edge?
A couple of things. One is the role of the traditional backend is going to change. It's going to become more lightweight to allow scale. And you're going to see more and more of that heavy lifting pushed out to the edge. And the effect that's going to have is it's going to drive the need for more powerful but low power, cost-effective silicon closer to those edges. So the old idea of a traditional IoT gateway was really a dumb device that collected information and forwarded it, and now it's going to be much more involved in the value chain.
What are some of the applications that excite you the most?
I'm really excited about where AI is going as a technology. I think that more and more high-speed interfaces at the edge, in vehicles, in IoT gateways, and so on. I think automation is a huge area that is ripe for innovation.
What industries, from your perspective, are the most ripe for disruption at this point?
Well, I think there's a lot of room in something that's near and dear to us, which is in the automotive space. There's a lot of initiatives going on with smart trailer, platooning, a lot of things going on with over the road and heavy equipment. But I also see in mining, oil and gas, in particular industrial IoT, a lot of room for advances. It's almost like when you look back at medical devices, there were these giant things that you'd strap on a patient and record with a tape, an analog tape, for hours to get like a heartbeat. Now there's a little teeny device that goes in somebody's pocket and does the same thing. There's the same kind of room for innovation in these fields.
What do you think about cameras or image sensors? What have been some of the applications that excite you the most?
Pretty soon everything is going to be video. It's all about video right now in the automotive, over the road, and even equipment space. Cameras are critical for a number of reasons, but obviously driver safety is one. But probably one of the biggest ones is to avoid lawsuits and use forensics, around accidents and events like that. ELD, logging of driver hours, behavior, et cetera. So again, back to AI, more and more AI is making its way into these camera systems. Right now, one of the issues with it, though, is it's kind of island AI is what I call it. I mean, it's stuck with the camera itself, and there's not a lot of correlative AI that can look at, hey, this is what's going on in the vehicle itself. It's at this speed, it's got this much gas, and this is happening with the driver and around the driver. So that's the next big wave, I think, that's coming with cameras.
So I think the phrase that I've heard is multi-sensor fusion.
Yeah.
What do you, from your perspective, what is the best way to accomplish multi-sensor fusion and provide value from it?
Yeah, so this in a way ties back to what we were talking about a minute ago, which is more intelligence at the edges of the networks. So to be able to do correlative multi-sensor fusion type applications, you've got to have the horsepower at the edge to do that. Yep. So you need higher end devices. Doesn't necessarily mean more expensive because, as Moore's law dictates, things get cheaper over time as with more integration. But bringing that capability of multiple feeds from sensors, cameras, vehicle data, whatever you want to add to that, to a common point at the edge, not having to backhaul it all to the cloud, is really a big key because it won't scale, trying to backhaul all that data.
So something we talk a lot about is the difference between microprocessor compute versus FPGA compute. From your perspective, what's the kind of the trade-offs of both, and from your perspective, which one has more of an advantage?
It really depends on the end application. They both have their place. Micros are really good at obviously general purpose compute. You know, if you're doing things that are well emulated in software, it's a great fit. FPGAs bring more of a hybrid approach. All the modern FPGAs have micro cores, usually ARM cores or something like that. But then they also have kind of a sea of programmable logic that lets you do application adaptation to the environment. So for example, if I'm doing something in, you know, a smart factory and I want to do machine control, I can instantiate, you know, motor control cores or something else to, you know, control robotics and sync the systems together. FPGAs are really well suited for that.
Beyond those applications, we talk a lot about connectivity, and there's been a lot of changes in connectivity in the last few years. What are some of the connectivity innovations that you've seen that you think will be either additive or disruptive to the total IoT stack?
Mm-hmm. Well, I mean, there's a number of things. So for one, a few years ago in IoT, there was like a smorgasbord of, you know, what you'd call PAN or WAN protocols, right? There is LoRa, there's, you know, Sigfox, there's Zigbee, there's all these things competing. And the reality is the market's shifted down to really two primary, you know, personal area network wireless interfaces, and that's Bluetooth and Wi-Fi. For remote connectivity, cellular is, you know, by far the dominant technology there. Within the cellular space, you know, we're seeing a lot of evolution with 5G coming out, you know, cheaper data plans, and, you know, what's on the horizon very soon is private LTE, which lends itself really well to things like construction yards or, you know, even platooning, where you want to create a private, secure, high availability, even redundant network with the high bandwidth of cellular.
So in this case, when you're talking about that, you basically get, from what I understand, all the benefits of a traditional LTE cellular network, but you have the entire stack, and you can use it any way you see fit. Can you unpack that a little bit?
Yeah. So when you're talking about private LTE or even 5G, you know, private spectrum, there's a bunch of different solutions out there. But the idea is that instead of a cell tower, you've got a small cell, which is a small device, which can either be mounted to a pole in a construction yard, it can be mounted in a vehicle, which is how they're using it for public safety today. And what it does is it creates either a mobile or a stationary footprint for cellular communication with maybe up to a mile radius, so it's a limited footprint. But you can essentially run whatever data you want privately over that. So it's not going through a provider's core or back end necessarily. You can get away from the data rates that are associated with that. The only thing you really need is internet connectivity back to that small cell. But you can have maintain mobility. So for example, if you're in a mining application with heavy equipment and you've got a bunch of vehicles that are going further and further down a mine shaft, you can have small cells periodically, you know, every so often posted into that environment, and they'll still seamlessly hand off as if they were going from tower to tower. So it creates a lot of really flexible options.
Yeah, that's very interesting. So I think that opens the door for a different part of the IoT stack, which is smart sensors. So whether it be regular cell from a traditional carrier or small cell, what role do you see smart sensors having in the IoT?
Yeah, so there's definitely a big shift towards more intelligent sensors. Again, with integration comes, you know, new possibilities. And, you know, instead of having a sensor, the old model is you've got a dumb sensor that speaks some WAN protocol to a gateway, and then the gateway packages that all up and sends it back to the cloud. More and more we're seeing integrated LTE directly into these sensors, and that's becoming actually affordable with the integration that's going on.
Any applications that are more exciting to you in that area or not?
Yeah, I mean, it's all interesting to me. I think that sensor integration is a really key thing to keep our eye on, but I think more of where I'm excited is more in the gateway hub arena, where, as we were talking about before, you've got this rich data environment where you can really add value with AI, machine learning, analytics, prognostics. There's, you know, video, bringing it all together and making that data combined have synergistic value.
any other technologies out there that are exciting that doesn't even have to do with IoT? I know you're a student of all kinds of different kinds of technology. What's gotten you fired up recently?
I really am probably mostly buried in the IoT stuff right now. It's been my main focus, but yeah, there's some cool stuff with autonomy that's going on, smart vehicles, electric vehicles that's really interesting.